Present. Thank you for being here, guys, today. And today I will talk about data observability and lineage, specifically field level lineage. My name is Xuanzi. I'm a backend engineer working at Monte Carlo Data. I joined this company last June. So it's been over a year. I've been mainly focusing on building field level lineage within a data warehouse and between tables in data warehouses and other BI tools like Looker, Tableau, and Power BI, things like that. Before Monte Carlo, I was working at Uber for a couple of years. There I was building streaming data pipelines, basically using Kafka, Flink, and those kind of tools. And before Uber, I was working at Google for 2.5 years building data warehouses. That's why I really enjoy working in the data area. And when I was looking for a startup, I chose Monte Carlo. Monte Carlo Data is the leader in the data observability category. We actually created this category. Right now, we are at Series D with 230 million in funding, and we have over 150 customers, including Raven, CNN, and PagerDuty, and a bunch of other great companies. So what does data observability actually do? Which kind of problems does it solve? Our focus area is data downtime. Our founders went around and asking hundreds of data leaders why data downtime is happening. As an engineer myself, I know that in data teams, we usually set up extensive monitors and alerts to make sure our pipelines are running fine, but the data downtime still happen. The crux is not because of bad data technologies or bad employees, but basically the impossibility of scale the workflows to detect and then resolve the data issues as the team grows and the data volumes increase, and also the expansion of our tech stacks in general. As you can see here, usually when people working on the upstream, ingesting data, they are not fully aware of what are the teams downstream using their data and how those teams are using their data. And the downstream teams usually would not know if there's a change on the upstream unless something bad happened at their side, like an incident that's already happening. Bad data can really causing trust issues with end users, and in general, it can impact our business massively. This is based on our observations and research. There are generally around 70 severe events happening, incidents happening among 1,000 tables per year, and in average, 30 to 50% of the engineering time in a data team is usually spent on fair drills. And these kind of problems are estimated to cost millions of dollars in the companies. Yeah.
I'm sorry, I didn't need my computer to do that.
Oh, no worries at all. Yeah, no worries. So how can data observability solve problems like this? At Monte Carlo, we are approaching the problem from 3 different stages. First is prevention, and then is detection, and the third is resolution. To help our customers prevent data incidents from happening, we have auto-generated dashboards of insights. For example, the users can come to Monte Carlo and say how many data warehouses they have and how many tables they have within each of the data warehouses and how healthy those tables are. And we have schema change notification settings and notifications set on every table. That means if there's a table schema get changed, if you add a new field, you remove a field, or you change the type of a field, the data owners will get notified. And also people in the downstream who may be using this data set will also be notified. And we are also providing a tool called Circuit Breaker. It's actually a library. You can embed that library into your code. When the Circuit Breaker detects something wrong with the data, it may interrupt the data processing part. And even though we try to prevent the data incidents from happening, it still happens. So when an incident happens, Monte Carlo tries our best to provide tools for our users to detect the data incidents. We have ML-based automatic anomaly detections. If you're using Monte Carlo, out of the package, we provide anomaly detections on your data volume and also on your data freshness and things like that. We also enable our users to create their own monitors and SQL-based customize the rules. For example, you can add a rule saying like, if the value of a specific column in this table is bigger than a certain percentage, then we should probably get a notification or something like that. We're also integrated with lots of like notification channels like Slack, email, PagerDuty, Microsoft Teams, and a bunch of other channels to make sure that our users will get notified when something's happening. And lastly is that we all need to resolve an incident when something happened. One of the tools we provide here, like one of actually most important tools we provide is a Lineage, specifically field level Lineage. Field level lineage can be used a lot in like root cause analysis. And based on that, we are building other tools like impact radius assessment of an incident. And we're also in the process of building many other tools for root cause analysis along this. So what is actually lineage here? What do we mean here? And how can we use it? Lineage basically is the derivative relationships between tables within a data warehouse. Or it's like the relationships between some tables in a data warehouse and some BI reports in like Looker, Tableau, or somewhere like that. Lineage can help answer questions like, for example, if an incident happened in table A, is that actually caused by the other incident happened in table B, which is an upstream table of the table A? Or like if a style table or model or reports is caused by like another style table that's in the upstream and things like that, or if it's safe to delete a column so that there's no impact on the downstream. At its very basic level, field level lineage can help to reduce the TTD and TTR massively for like data issues. That means like the time to detect and time to resolve those issues. Actually, our users have been using field level lineage a lot in different ways. For example, there's this customer, they are a 400 person fintech company. They are generating the monthly revenue reports using data collected in Snowflake and then visualized through Looker. They were actually using our field level lineage to trace down like a table in their data warehouse with a source field that's contributing to some suspicious number that's appearing in some broken dashboard. And by traversing through the lineage, they figured that actually it's some upstream DBT model that failed to run. And many of our customers actually trying to leverage field level lineage to deprecate columns in frequently used data sets to ensure that like outdated objects are not used in reports for end users and things like that. With field level lineage, it's very clear for them to say if a field appears in some downstream tables or not. Another thing is dealing with PII, like personal identifiable information. Several of our customers are dealing with really sensitive data. They need to know like which columns contains the data that link to some dashboards downstream that are shown to the end users. Just by being able to connecting the dots with the columns having those PII information to some downstream reports, it helps them to like easily make decisions to whether to, you know, remove that field or hide the reports from the relevant parties and stuff like that. Basically, with field level lineage, there are a bunch of things we can do with root cause analysis. So at Monte Carlo, first of all, we are surfacing the lineage to our users through API and also on our UI. As we can see, this table, this panel is the table level lineage. Sorry, it's a little bit small. And also we have field level lineage panel down here. At the table level lineage, you can have a comprehensive picture of like the middle table. What are the upstream tables that contributes to this current table? And also on the right side, what are the downstream tables or reports? Like in this case, it's a Looker view that are influenced by this current table. And for field level lineage, when you come to this panel, you can click on one of the field. For example, here we are at the created on field. Then this field will show in the middle of the panel. And on the left side, you can see this the lineage for this field. The selected clause lineage means that this field on this source table are contributing value directly to this column in the middle table. And the non-selected lineage here actually means these fields are used like in a where clause in terms of queries to influence which rows will be ingested to the table in the middle. Similarly, on the right side, we have selected clause lineage. Column here means that the column in the middle table contributes value to this column directly. And for tables that don't really have like selected columns there, it means this field is using a where clause to help influence the which rows are ingested into all the other tables or dashboards and stuff like that. And on top of the lineage, we built something called impact radius for incidents. That's like when an incident happens at table level, we would generate a chart like this, basically showing our users like how many tables are directly affected by this incident. And this table is used by like how many users in the data warehouse and how many queries are actually using this table may get affected. And along the lineage going to the BI world, we can see how many reports actually get affected because they have this table as their upstream source, and how many users who are using the reports may get affected and stuff like that. And recently, we just launched a new feature called the field level importance score, which is basically calculating a score for each field within a table based on like how this field is used in some downstream tables or like BI reports, so that when you want to clean up the table, you'd be cautious about like, do you really want to change the column and stuff like that. And we are building many other tools based on field level lineage for root cause analysis in the meantime as well. Sorry.
Do you track just across tables from the same warehouse, or what about like data coming in from other systems, like maybe from API, or
Yeah.
how do you track it the same way?
Good question. Actually, right now we only have the lineage within a data warehouse and also between the warehouse to BI tools. Like honestly, from data warehouse to BI tools is through API. Since like usually, for example, Looker, they will provide you API to tell you which are the data sources. So we build lineage that way. And we do that for Spark as well. But for many other like data lakes or like other systems, we just don't have those lineage yet.
So you can't go back like into source systems, ERP, SAP, Oracles, or any of that. You're really just in that data warehouse and the analytics.
Right now, yeah, but we are still building, like expanding to other like data systems like Oracle and Mexico. Yeah. And yeah, I just want to go to the technical part about talk about how we actually built the field level lineage at Monte Carlo. So at database level, everything is a SQL. No matter you're trying to create a table, delete a table, change the scheme or ingesting data, it all goes through SQLs. So our lineage is built on top of parsing the queries. This is a general architecture of how we build the field level lineage end to end. We are a SaaS company, so we have a data collector that sits at our client side in the client cloud usually. And this data collector will collect query logs from our users' data warehouses periodically. And after collecting those query logs, it will emit those events into an AWS Kinesis stream. And on Monte Carlo side, we have some Lambda functions. We call them normalizers. The normalizer will receive the query logs. And for each of the query log, it will try to parse it through the query parser Lambda. And like you can send a query to the query parser Lambda and return the raw lineage. And after receiving the raw lineage, the normalizer will try to resolve those source columns and tables by like verifying them against the metadata we have about those tables in our database. Once like the sources are resolved, the lineage data is streamed into another Kinesis stream. And after some further processing in the data loader, the field level lineage is indexed into Elasticsearch, so that like our server, right now we have only one like monolith server, can query Elasticsearch to fetch the field level lineage and serve it through APIs to our users directly or to the UI. This is actually a pretty standard architecture for data processing. The most challenging part for us was building the query parser lambda part. So the query parser is basically a lambda function. It takes a query as an input and then extracts the lineage data as an output and send back to whoever's calling it. In the example on the right side, as you can see, like for the simple query, we are trying to select column 1 and column 2 from a table named table with a where condition that column 3 equals to email. After the query parser receives this query, it will pass it and generates an output like this. The format is generally like this. The sources will contain a list of strings. The strings are basically the table names that are used in the query. In our case, we only have like one table named table, so it's only showing here. The non-selected columns are showing the source columns and its source tables from the where condition. In this case, we only have like one column, that's column 3, used in the where condition. So we are only having that column 3, and we call it prefix, but it's actually the source table name here. That are used for the where clauses, and the columns lineage part contains like the lineage for the fields in the selected clause. As you can see, we have like a selected column. That's the name that will show in the result of the query. And it will have a list of column sources, which contains pairs of like source table and source columns. Since our query is pretty simple, so for each of this selected column, we only have like one source table and one source column for it. The selected index is basically the selecting order appeared for those columns in the select clause in the query. The indexes are important for queries like insert into as select when you have like predefined column names and stuff like that. And our query parser is built on top of ANTLR. ANTLR is like a very powerful tool for generating parsers. It's widely used in building languages, tools, and different frameworks. By using ANTLR, you can define the grammar, and ANTLR can generate a parser based on the grammar you define. And this parser can take a string as input and then parse it out as a tree structured object, which contains all the different elements. And then you can basically walk through the tree and then extract the information you need. Our query parser is built on an open source ANTLR grammar for Presto. And on top of that grammar, we added support for Snowflake, BigQuery, AWS, Asana, and Redshift. For now, we are definitely expanding it. It's still in the progress. Yeah, as we mentioned that ANTLR will basically generate a parser which can parse some string. In our case, it's basically parsing some query and then generate a tree structured object so that we can extract the column lineage information from it. Like ANTLR is traversing the two through two different patterns. The first pattern is called the listener pattern. The second pattern is a visitor pattern. Both of these patterns traverse the tree through DFS, which is the depth first search pattern. The difference is that when you're using a listener, you can define functions on specific node types. For example, if I define a function on select clause or something like that, then when the tree, when ANTLR traverses through a node that has the select statement, it will just do some operation there. At the beginning, we were actually having a parser based on the listener pattern. It helped solving like over 80% of the queries that we had, but there was some like complex cases it's just not able to help resolve. For example, like this query, it's really small. It's actually a not too complex query. It just have lots of like things in there. Like as you can see in the with clause, there are 9 like common table expressions defined here, and some of the common table expressions down here are using the common table expressions defined up here. So when we are like going into, for example, here this united common table expression, we need to parse like the enabled and all the other common table expressions recursively to actually extract those information. With listener patterns, it's really hard to basically parse things like that, since you kind of traverse the nodes in a flat manner. You can't really pass states, sharing states between parent node and children node. That's why we actually had to switch to the visitors pattern later. The visitor pattern basically gives us control while traversing through the node. Like on each node, you can see whether I want to go to some of the children, or I want to skip some of the children, or I may keep some states for the children to use later. In our case, for example, the union common table expression, we can call it a subquery here. In order to resolve this, like we can parse all the other resolved queries above it to the subqueries within it, so that the subqueries within it can be resolved. And also, like in some really deep nested subqueries, we need to pop out the resolved results from like the most like inner one to the outside, so the parents can actually use the resolved children's lineage to resolve itself and stuff like that. So with visitors pattern, it really helps with that. Yeah. So this is like definitely a whole team effort, and we've been going through this like back and forth with the listener and the visitors pattern, to eventually arrive where we have now. And there are still like lots of new corner cases coming up, and we're improving our query parsers along the way. Yeah, those are like the main content I have for today. This is my contact info. Like if you have any questions or interest about data observability or like lineage related stuff, please feel free to reach out. And also, like if you like, you can register for our Impact conference, which will happen in October. It's free and it's virtual. And we have some like amazing key speakers registered already, like Daniel Kahneman, who's the author of Thinking Fast and Slow, and the Nobel Prize winner for behavioral economics as a psychologist. And also we have like CEO from like DBT Labs, founders from like 538, and lots of great other speakers coming. Please feel free to register. And lastly, we have a book called Data Quality Fundamentals. If you click through the link, you can get a free copy, just if you're interested. Yeah, that's all. Thank you.
Have you ever heard of Thomas Redman?
Thomas Redman? Oh, I don't know him.
He wrote the original book on data quality at Harvard.
Oh, really?
So yeah,
I should read that.
Check that. On data quality. So you're basically, your system is taking the queries that you see out there from a data log and different projections that people are doing on the system.
Yeah.
Parsing those queries and understand the data lineage of what they have basically between their different source and target zones. And then you take that data, and I'm not sure what you do with it.
Oh, so we take that data as we show here.
And can you share your slides, because
yeah, sure.
It's hard to see behind you, and
Mm-hmm.
you're recording it, but it's like it's not showing. It's just showing
yeah.
your pretty face.
Yeah, I can share it. So let me see. It's like people with links. Actually, I probably have to. Which only people with access can open the link.
Well, I can give you mine. Well, you might need your
I'll see if I can just share this in the chat.
You might.
But I think I can only share with the.
It's shared in the chat.
Yeah, do you see it?
Yeah.
Oh, awesome. Yeah, if you can see.
Online, that's what I was saying, because you're displaying. I was telling you just your face over that. And, the slide is kind of hard to read, but I see it in the room, so that's cool.
Okay. Yeah, I'm not sure what's like a better way I can share that with everybody else.
It's asking me for access and request actions.
Okay.
So once you get the data out into these different places, so the key value is that you can give a data lineage on it. I guess the concern I have is
Mhm.
if you start to do a lot of remapping of files,
Of
can you
files.
cross-reference as the field name changes as it goes through different systems?
Go to different systems.
Yeah.
For now, we can only link like data warehouses to BI tools like Looker, Tableau. But for other systems, we don't really support at this point.
I
Yeah.
get you, but
Yeah.
I'm just saying, like, if let's say I was sitting in my, and I had an ETL process that was gonna change it from, you know, first name, last name to first name in a field and last name in a field. Can I see that relationship?
See that relationship. If it's through a query, yes. But if it's like code change, for example, if you write your own Spark code, then probably not.
So like maybe
Yeah.
you can like maybe like an ETL code or something like Informatica.
Yeah. Yeah.
And then you will have a different layer like OBA or OBA, you will have a physical layer, different model, different layer, the different naming. But the sum table the same, but they present the different name, different model.
Different systems.
Yeah, different layer.
Different layer.
For the presentation layer, they call the name, last name, but actually physical table, they call the L name.
We are just taking whatever's in the physical tables names. Yes. Yeah.
You're not looking at the end report, you're looking at the data as opposed to the analytics, right? So each
Yeah.
of the data fields, so he's not looking for like what the OBIE would actually call it.
Yeah.
I mean, I'm saying that, I'm not, I think that's what you said.
Yeah. Yeah.
Yeah,
Exactly.
for the field level important score. For Snowflake, if I do the time travel reverse back, is it going to revalue it again? Or I have to manually process or automatically?
So the field level importance score, we actually calculate it at Monte Carlo side based on the lineage we have.
But it's only one time, but one
Yeah.
time. Go back, or like a time travel.
Yeah.
Different version, the table structure changes back then. Your script or your process will be again.
If it goes through like some queries, yes, since we would put like the whole picture of the lineage, it goes like along the way, along the time. It's not like one time thing and then stop there. Yeah.
First time I heard it too.
Yeah.
So are you combining that with existing metadata around each table?
Yeah, we
Something
collect
like star queries, like so that you're
star queries.
yeah, like a simple select star query.
Oh yeah, we can parse that. Yeah, that's why we need the resolution that's happening in the query log normalizer, right? So we try to first parse the query, and then based on the results, we want to check it, validate the data against like the source table and columns in our database. If it's like select as a risk, we will basically expand to the whole table of fields. Yeah.
And then you're able to handle the changes as they happen.
Yeah, we also select like the select star except in BigQuery and stuff like that. Yeah. Any other questions?
Thank you.
I guess that's it. Thank you so much for being here.
I sent it asked me for